before we start, how many of you actually already heard about Clojure? So, some guys. And who tried it already? Who is using it in production or just for fun? OK. So about me, yeah, so I am just software engineer at Allegro. I know Kung Fu really good, so if you have any objection to my talk, better keep it for yourself. And almost all things that I will talk about, it was already invented. It's nothing new. So, so the question is, what we are doing? So in late 70s, on MIT, when you started computer science, and you have basic introduction course, a professor, Howard Abelson, wrote on the table computer science, and then he crossed out science, because it's obviously not a science. It's maybe some kind of art, maybe some kind of engineering, a bit of magic, but not a science. And then he crossed out computer, because what we are really doing is not about computer itself. Like physics is not about particle accelerator, and like geometry. So geometry comes from, Gaia Earth and measuring. So it's about measuring the Earth, because in ancient Egypt, priesthood invented geometry in order to figure out how to restore the boundaries of fields destroyed by annual flooding of the Nile. So what is the true essence of geometry? I don't know, but basically not measuring the Earth, maybe some kind of triangles or something like this. So this is the good question, what we do? So what we do, what would you say? Don't be shy. Nope, nobody? Programming. So developing software, maybe. So there is an excellent book coming from late 70s as well, The Mythical Mammoth. I don't know if anybody of you already read it. I really strongly recommend it. It's a very nice book. It seems all the things are pretty current, actual. So in this book, there is a story. Let's imagine that you have a team of 5 developers, and you provide some software for. You wrote it in 1 year. You come to your client, and he is throwing out this into the trash, and he's asking you, how much time do you need to rewrite it? What would you say? It took 1 year. What it really took again? Any guess? Half year. Okay, half year seems reasonable. So basically the question is, what happened in the other half? Sorry. Struggling with the problem. So maybe learning how client's business model works, maybe learning agreements, maybe building up the teams. I would say that those things are extremely important, because if it takes so much time, that it's half of the time at least, it means that this is actually what we are doing. We are managing the processes. And yeah, obviously, this is actually what we do. We are earning money for our clients. And how all these things are leading me to the Clojure. So when you start a new language or a new technology, usually it's like this. You open a YouTube and see some presentations, and somebody is making maybe blog, maybe e-commerce in half hour or something like this. And it's maybe not really convincing. But when I started with Clojure, I had, so anybody recognize this guy? So this is Rich Hickey, yeah, he is creator of the Clojure. So, and on the very first presentation, on the very first slides, it's a snapshot from the slide. So he is talking about cost-benefit ratio, about time to market, about profit. So, yeah, it's quite curious things. And then I come to some kind of website and start asking questions. Obviously I'm a web developer, so I would like to have some nice, shiny web framework, and I ask which one is the best when I want to start with the Clojure. And they said, okay, it's not working like that. They are not using framework. There are some, but they are not using them because they have very tiny, small libraries that doing work well. And what is extremely interesting about it, some of them, when you go to the GitHub, they have like no commits for 2 years, but if you ask the main committer, he is responding back very quickly because this library is feature complete, so it's just working. Never seen that before. So who is writing object-oriented code? Yeah, don't be shy. And functional code. Some hands, three, four of them. So what does it mean? So what does it mean to write object-oriented code? Any guess? So when I have objects, there is object-oriented code, right? No. So I would say that object orientation is about, so any paradigm is about what you disallow, not what you allow. So object orientation takes some restriction on how you use polymorphism, and functional programming is basically taking, so what is making functional programming? What does it mean? Any clues? Come on, don't be shy. Nope. Okay, so basically functional programming, I would say, is about immutability, about how to manage the state. So, and this is a very interesting thing. So anybody recognize this guy, this time? So it's Uncle Bob. So it's like a rock star of Java development. And from several years, he is talking a lot about Clojure. There's a lot of buzz about it. And during one of his talks, he is pointing out that this is an excellent book. You should really read it, Structure and Interpretation of Computer Programs. So, and in this book, you have various concept after concept. It's going through the whole computer science thing very quickly. And then on 200-something page, they stopped, and they start to apologize. They apologize for making a very dirty thing. They introduce a variable. After 200 pages, they were able to not use any variables. All these queues and things without it. So it's really amazing thing. You should try it. If you think about it, usually when you start to teach anybody computer science, you start with variable. And it seems to be very difficult concept. It seems you can avoid it. And why this is important? So on the green line, we have number of transistors, and you probably knows the Moore law, that the number of transistors is doubled, so the scale is logarithmic here. And about 2003, there is something happened. The clock of the computer stops. We used to have at this time like 3 gigahertz, and now we have 2.5. So something stopped to work. We come to the limit, and the same will happen soon with transistors. Moore already said about it. So the question, what will be our response if we can't scale with just number of transistors on the same plate? So we have much more cores. Like we have 8 now, and Intel is claiming that they want to produce 100 cores. So, and basically the question is, if your favorite programming language supports this new paradigm, if we are able to write this code in a clean, clever way. There was a very short time that we were thinking that maybe hardware will handle that for us, but yeah, it's not going to happen. And this is another funny chart. It's the cost of memory, and this is major difference. We used to use our databases like 10 or 20 years ago, but yeah, this NoSQL thing I know, but 20 years ago, it was there. It was called C3. But there is something changing here, and memory is extremely cheap. And the question is if those kind of changing conditions should change way how we program things. There's additional thing that we have to admit that async is everywhere. Even if in a web browser you have user as async event source, and you have async communication with server, and most of the languages are ignoring this topic and provide you very, very poor tools to use that. Yeah, it looks like this. Every website, every server. Really amazing. So what is the difference between object orientation and functional? Generally, in object orientation, you create a very nice tool to solve your problem. If any of you remember this game, I feel like this. You play, it's a very playful thing. And with functional thing, you have nail gun. You just shoot it. And every problem you can reduce to transformation of data structure. So you have always the same data structure. We will come back to this topic soon. So a short visualization of how it could look like in case of object orientation. So the quiz. What is the most frequent code in JavaScript? Yeah, I know. This is DevOps conference. This is no JavaScript guys here. Any guess? I guess it's this thing. And what is the most frequent code in Clojure? Yeah, so this is obvious. The same. And actually, if you think about it, there's less brackets here, even than in JavaScript. So it's a common myth that it's more, but they are placed in different places and a bit different shape. So then everybody is running out when they see that. So what was my first impressions when I started? So it was like this. When I start to people, yeah, they looks like this. So how it look like? So I couldn't resist to talk a bit about John McCarty. So it's creator of the Lisp, and in the late 60s, he invented, because he needed some kind of tools to deal with artificial intelligence. He invented Lisp, interpreters, high-level metaprogramming, garbage collection, dynamic programming, functional. Generally, he pushed forward a lot of IT. So if you want to write any software in Clojure or Lisp, if you have usual function, like here, you have to imagine that this bracket you will take back here. And it's there, and commas are optional. And it's all the magic. So it's, you already know the syntax. You can write the code. So this is some kind of example. So, for instance, we can have variable x equals 1, and this is not really variable, this is constant, but it's very similar. So x is 1 here. We can define a function, so this is anonymous function. This anonymous doesn't have any name. It takes one argument, and is multiplying x by x. Yeah, so power of 2. We can assign it to no, not variable, but we can give it a name like f, and yeah, some kind of brackets at the end. There is a shortcut for that to make things easier. So yeah, and there's how we call it. So basically, in this parenthesis, the first thing that you spot is always the function, and it will be evaluated, and the rest thing is arguments. And you have data structure like list and vectors. Basically, it's not very big difference between them, but in list, the usual thing is here will be the function. And there are some maps, and this kind of things, they are called keywords, and it's like in Ruby. There are keywords. If you want, you can think about them like about enums and sets, and everything can be nested. And it's all of that. It's nothing fancy here. But what is quite important, those things are persistent data structure. They are immutable. So why is it important? Why do we need immutable data? Come on, guys. Okay, so generally the thing is that if we want to write concurrency code, if we have immutable data, it's much easier to write the code. We don't have to use the logs, and it's much easier to reason about and to write it. And how it works, you basically have the list. If you want to append one element, you don't copy or write. You reuse the previous data structure. So it's quite easy and fun, and it's working for set and maps as well. And it provides Taylor recursion, because if you want to write functional code, usually you would like to write in a kind of recursion. And then the problem is occurring that you will quickly fall in this Stack Overflow problems, and you will have issues with that. So both Clojure and Scala provides you some kind of tools to reuse the stack frame. So it's a pretty nice thing. And it's like this chess. So you basically have very simple rules. You probably know already all the syntax, because I just show it. But the results are quite interesting. And here's some kind of Lisp keyboard prototype. Don't worry, there will be some code. But I have to warn you, because Jacek Laskowski was traveling through the Poland showing Clojure several years ago. And when he was showing the code, people started to move slowly to the exit doors. So a lot of people are afraid of this, what you will see. I made once a presentation in my company in Allegro, and it was a very nice presentation. People were happy. But after this, somebody asked for showing the code, the production code. I showed them, and they were not interested at all in that. So be careful. Okay, and this is the game of life in Clojure in 8 lines. And you are not supposed to understand this code right now if you are not familiar with the brackets things. But what is my promise? If you start to learn Clojure, this will be very, very clear and very readable code. And even you can read what is happening from the code, what kind of algorithm is here. So it's a very nice thing to try some Clojure and go back to the slide and then see how expressive is this kind of code. So let's talk about Java. So first, I have to make a statement. I love Java. Java is my favorite language. It's my mother tongue. So don't get me wrong after this presentation. So this is HttpServletRequest. You probably already use it or recognize it if you have any Java code in production. So could you say where are the maps here in this interface? This is half of this interface. Where are the maps? Do you see some of them? Okay, so we have one. Yeah, it's quite difficult. Yeah, there are some. So there are 4 of them because HttpServletRequest itself is a map as well, and every of them is providing you different types. So some kind of list of strings or special types and so on. So it's very broad, inconsistent interface. And when you use this kind of code in your application, then you are bundled with that. You have to, your piece of code have to understand that there is something like HttpServletRequest. You can't use the tools that you usually use for maps, for processing the maps. If you have any code that is processing the maps, you can't just apply it. And it works like that. If you have web application in Java, usually the request is coming in form of the map. In form of the map. Then you are translating it to this object. Then you have some kind of DTO object, and then you are providing it to your service layer, which is wrapping up in some kind of model object, and then maybe you want to put it in data source or something like this, and there will be another DTO layer. So basically, your application is starting just wrapping things up between different layers. So it's not very effective, I would say. There are several impressions about that, and yeah, there's your map, and we are coming through different layers, and it's what it's left from your readability of the code. In Clojure, you're just using the maps. You have the headers, the body, and so on. So you basically, it come a map to you, and you can use it as a map. So you don't have to understand that it's something special. There's no special thing about it. You have small. So basically, the question is how we come from this to that. So it's very, very good question. But you could ask if, there are some languages that are much better. Java is quite old, and this backward compatibility things makes some difficulties. So is this really the same? So like in Groovy, if you want to have a JSON, you can just write like this, and it's quite close to the original form. In Clojure, you just use the map and some kind of function that is escaping the code. So what is quite interesting about this, you have plenty of objects here, and if something is going wrong or you want to change something, you will have to go deep inside this library, and here's quite a simple map. And the same come with configurations. You have YAMLs, it's some kind of new syntax, and in Clojure, you just use the map it's just a subset of the language. Just you use regular language data structure to express your configuration. It's just very simple. You don't have to parse it. It's just there. And this is my favorite example. It's coming from Scala. Do you see this parentheses here? If you stack them together, it will be quite similar to something. And this is another example doing basically the same in Clojure, but there is less brackets here. Yeah. So this comes to Greenspun 10 rule. So any sufficient complicated C program contains ad hoc informatically specific bug read and slow implementation of half of common Lisp. And some guys say that it applies to common Lisp as well. So, yeah. There is another, because a lot of people are saying, okay, but all these things, the brackets, I can't read the code. It's very hard. It's very unnatural. And if this is some kind of example from Java web application. And if you want to read this code, what you actually reading is that you are looking for these things. The rest is just decoration. It's just additional things. You have to find these things in that. And this example in Clojure, you will not understand it maybe right now, but it's much less gray area here. You don't have to look for this code. It's much more compressive. And because I make a lot of jokes about OOP, so let's give a quote here from Alan Kay. OOP to me means only messaging, local retention and protection and hiding of state process and extreme late binding of all the things. It can be done in Smalltalk and in Lisp. There are possible other systems in which this is possible, but I'm not aware of them. So basically, you can write object-oriented code in Lisp. So it's quite an interesting point. Yeah, I will. So not everything is awesome. So what I fear about Clojure when you want to adopt this. So the first thing is dynamic typing. So basically, if you want to go to refactoring or understanding the code, you may be afraid of dynamic typing, surely. So yeah, because refactoring usually looks like this. Yeah, it's been there, done that. But how it looks like? So at Allegro we have microservices architecture, so it's some kind of Trojan horse. It's very easy for language polyglots. It's very easy to sneak around and put something new on the production. So we took, because I'm talking of this refactoring thing, we took one simple REST service, was 2K lines of code in Java, rewrite it to Clojure, and it was about 150 lines of code. So on my 27-inch screen, it's just one screen. So if you want to refactor, it's extremely easy because it's just one screen. How about bigger applications? Don't write them. You should write small applications. It's simple as that. So most people say that it's 1/5 of the code base. You can use all the things from the Java. So if you are afraid that something will be missing, it will be there in Java. But adoption of the new language is very hard because you are not asking people just to learn a new language. A lot of times, those people are identifying themselves as expert Java engineer or something like this. Maybe not on the DevOps conference, but there will be a lot of people like that. And if you ask them to learn a new language, maybe they have to deny their own identity for a moment, or they have to push the ego away and all the things that they already know. With it, maybe this is the last language. So this is the name of the excellent talk of Uncle Bob. And in this talk, he asks the question if we already have seen all the languages. Of course, there are some new languages, but there are always different combinations of the same concepts. So, this is a very good talk. I really recommend it to see it. So the major selling point in Clojure in the longer run, it's homogeneity. So it means that you can take Clojure code and process it in Clojure. It means that if you want to have a new language feature, you can just write it. And I will come back to that. So there are other interesting things, like Clojure script is basically Clojure hosted on the JavaScript machine. Hello World is 2 lines of code. Why I'm saying about it? So there are a lot of different languages transcompiling to JavaScript. One of them is Dart, and it was quite infamous because the first version, they have their own JVM, but nobody is using it, so they make transpilation to JavaScript, and the first version of Hello World was like 5K lines of code. But it's much better now. So is it slow? It's not. You can check it. Debugging is quite a nice thing because in the browser you will see actual Clojure script code. So it's a very nice feature, and they have some people around it, so it will not die tomorrow. There is Clojure Async, so it's excellent thing. So this is the major selling point, I would say. So this, if you know Go, there is a very nice way to treat concurrency, and it's basically works like this, that you have channels and you can put them and take things back from them. And there was no such thing in Clojure, but somebody take it and wrote it. And if you want to have a new language feature, you don't have to wait for your provider or of your compiler. So how to learn it? So one website is for Clojure. I highly recommend it. You can just make some exercises. It will be fun. There is a lot of books. So one that I truly recommend is Clojure for the Brave and True. And the hype is coming. There are a lot of people saying about Clojure. So this is the thing that said Adrian Cockcroft. So he's former cloud architect at Netflix. And this is, go to market faster, better quality, avoid interruptions. So senior architect of Wallmart apps. So Wallmart is very intensively use Clojure. There are some companies that are using Clojure. Of course, maybe they have just one script, but as far as I remember, Puppet Labs wrote this Ruby server into Clojure, and it's very common things. A lot of people in Ruby society, they are using Clojure to making things faster, which is quite interesting. And there is popularity rank on Stack Overflow on the vertical axis and popularity rank on GitHub. And Clojure is like here, there. So together with Haskell and Groovy and Go and Swift. So it's quite popular language. Can you imagine? So Lisp language in 2014, I think it was from 2014. And this is Tech Radar from ThoughtWorks. So Clojure is something here, adopt. That's all. So any questions?
We have a time to ask a few questions. Do you have some?
Don't be shy.
Okay, we have one question.
The Lisp has been here for about 40 years, as you said, and it hasn't gained any significant popularity. There were some projects like building Lisp machines, Lisp CPUs, and they all failed. What do you think will make Clojure to gain popularity and to not be like the old Lisp?
Okay, so one selling point is, the problem was that in the past the memory and CPU was very, very expensive. Now the expensive thing is your work. So basically those things changes, but all the languages that we are using commonly now are just the languages that are similar to C. And if the language wasn't similar to C at the time, it was very hard to get some popularity around it. But I truly believe that one of the best things that happened to Lisp and Clojure is popularity of the Scala, because all these people disappointed by the complexity of Scala will be triggered to Clojure, I believe. And this is the thing, all things around us are changing, and we will have to write software for multi-core architectures. So I would say that.
Any more questions? We have some time still. So maybe one for me. Do you know any company that has made a strategic decision to move from Java or any other language to Clojure?
Okay. So recently I was talking with guys from Daily Mail. So it's the biggest newspaper in Europe, maybe in the world. And they write whole stack to Clojure. They migrated all the things from Java to Clojure 2 years ago, and they are quite happy about it. So, yeah.
Okay, so already we have some companies moving forward, I would say. Any more questions from your side? So I think it's time for lunch. Thank you so much for your speech.
Thank you.